All right, so multiplying polynomials. So for multiplying polynomials, a lot of it is going to look familiar. Most of the process is actually made up of things that we've done before. So you have done everything previously that you need to be able to do to multiply polynomials. The only thing is all of these different skills are being put together in a little more of an advanced situation. So it's kind of like, you learned how to use a screwdriver and a hammer and a saw, and now we're telling you to build a bookcase. It's kind of what's happening here. So there will be a lot that's familiar, but all of these familiar things are going to be used in a way that is a little different. All right. So there really isn't anything to write like definitions or steps wise. We're just going to jump right in, and we're going to look at our first example is actually going to be something we've done before, just because there is a skill that we need to take a second and review. So our first example, 3x squared times negative 2x to the fourth. So one of the main skills for multiplying polynomials is going to be the power or the multiplication property with powers. Product of powers is another way to say it, but remembering how to multiply powers that have the same base. All right. So, little refresher, this is not combining like terms. We're not adding and subtracting terms. We're actually multiplying. So, if we remember, when we have multiplication, I take my coefficients and they get multiplied by each other. My exponents, if I have the same base, what do we do to the exponents? Whoever said add them is correct. So what I'm going to do is I'm going to have my x to the 2 plus 4. Okay, so again, we're doing this example because we need to review this process. It's very important for what we're doing today. 3 times negative 2 is negative 6. X to the 2 plus 4 becomes x to the 6th. Okay. So again, when we're multiplying powers, coefficients get multiplied by each other. If the base is the same, we add our exponents. All right. So moving on from there, we're going to add a little level of challenge. So this next example is going to look familiar because we have something outside that's being multiplied by an expression inside. If you didn't have the x squared there, if it was just a 3, that would be distributive property, right? You've distributed a bunch of times, right? So we've distributed tons of times. So if it was just 3, I would multiply 3 times negative 7x to the 4th, 3 times negative 4x, 3 times 2, right? Little bit of a longer expression than what we're used to doing, but you could do it. The process is the same when we have 3x squared. Remember, this is just a number. We don't know what the number is. We don't know the value, but it is a number. So all that's going to happen is the 3x squared is going to distribute to everything inside. So we're going to distribute 3x squared. Now, in our notes today, I'm going to just write the extra step of work so that you have it in your notes. On the test, if you skip that part and there's a mistake, I can't give you I can't give you partial credit. So showing this step is a way to help keep you organized and it gives me a chance to give partial credit if that's a possibility on the question. And what I mean is I'm going to take the 3x squared and I'm going to show multiply by negative 7x to the fourth minus 3x squared times 4x. Okay, depending on what makes sense to you, you could do, your additive inverse where you make this addition and the negative 4x negative, and you could have plus 3x squared times negative 4x. Like, you kind of decide what makes sense to you. Keep that in mind. Plus 3x squared times 2. Okay, so again, in our notes, I want you to write this out. Number one, keeps you organized. It's a lot to try to calculate in our heads. And it just practices the process. So now I can go ahead and multiply each part. So all we're doing is the order of operations. I can't do anything inside the parentheses, so now I look at exponents. I can't do anything with my exponents. Multiplication, I can distribute. Now that I've done the multiplication for the distributive property here, I can multiply each of these. So I'm just going to multiply each section here. So I get negative 21, 3 times negative 7, x squared times x to the fourth. We add the exponents, right? So I get x to the sixth. If you want to write the step out where you show 2 plus 4, you can. Then I have minus 3 times 4 is 12, x squared times x to the first power, x to the third. Don't forget the x here has a first power. Plus 3 times 2 is 6, and there's nothing to multiply x squared by. So that's it. Again, if you skip this step like on a quiz or a test and there are some calculation errors, I can't really give you show your work partial credit. Okay. All right, let's look at another one. Try this one on your own. Oops. Not 2x squared, just 2x. So try that one on your own. I'll do it up here too, just so you can check yourself. See if you get the same thing that I do. All right. Next up, we're going to add another little layer of challenge. And now instead of just a single term on the outside, we actually have an expression. So we have 2 expressions being multiplied, or actually we've had expressions being multiplied, but instead of a monomial being multiplied by a trinomial, we have a binomial times a binomial. Okay? All right. So in this case, the only difference is I have 2 things that have to get distributed. I have an x that needs to be distributed, and I have a 2 that needs to be distributed. So just to keep it from getting tangled up, I'm going to take my first term here, the x, and I'm going to multiply by the 2x here. Then I'm going to take the x and I'm going to multiply by the negative 3. Then I have to distribute the 2. I'm going to draw my arrows underneath. I'm going to distribute the 2 to the 2x and the 2 to the negative 3. Now, when you get to high school, there's a very good chance that your teacher is going to talk about something called FOIL. I don't love acronyms, but it is something that you probably will hear a lot, just kind of as you go through school, so we might as well put it on your paper. But FOIL describes the order that we multiply things in. And it's not like the only order, it's just an order that is easy to remember. So it stands for first, outer, inner, last. First, outer, inner, last. It basically just describes the order of everything. So first, I'm multiplying the first terms together. X times 2x. It's like our first arrow here. So first terms get multiplied. Then the outer terms get multiplied. So first terms, outer terms, inner terms, last terms. So first, outer, inner, last. Or we just draw the arrows like we did here and distribute, okay? So we have x times 2x plus x times -3. So I could say plus x times -3, or we can say minus x times 3, however you want to write it. So either minus x times 3 or plus x times -3. Either way, you're going to get the same, you'll get the same simplified result, okay? 2 times 2x. And again, I can either say plus 2 times -3, or I could say minus 2 times 3, however it makes sense to you. I'm going to say plus just because this is a positive 2, plus 2 times -3. And then we start multiplying. So this is 2x squared here, plus -3x, plus 4x, plus -6. Or you could say minus 3x, minus 6, either way. Now in cases like this, we do have some combining like terms that we have to do. These two terms are both x's, so I do need to combine those. So my final answer will be 2x squared plus x minus 6. Excuse me. All right. Questions? Okay. It's a process where as long as you just take your time, show your work, it's like the same process over and over and over. Okay, so I'm gonna have you try one this way on your own, and then we're gonna look at 2 alternate methods. All right. Okay, example 5. So example 5, we have x minus 3 times the quantity x plus 4. All right, so take a second and work that out. Distribute my first terms, my outer terms, my inner terms, my last terms. I'm going to work it out quietly while you guys try. And I just made some notes on the side as to what we did, just in case you want to have that. What do you think? Pretty good? All right. So we are going to take the same expression and we're going to multiply it 2 different ways. Okay, so there are 2 other methods that you can use. So the first alternate method is to multiply it vertically. Okay, so the vertical method is very similar to the process when it came to addition. So when we were adding our polynomials, when we added vertically, we set them up just like you would set up large numbers that you add, right? We lined up by place value in regular adding, but with our monomials, or excuse me, our polynomials, we lined up by term, right? Our constants lined up, our x's lined up, our x squareds lined up. So the process with the polynomials matched the process with numbers. When we multiply vertically, the process for multiplying our binomials vertically is going to be very similar to multiplying large numbers. So for example, if we were multiplying, 25 times 64, you would stack them up, right? And then we would say 4 times 5, that's 8 plus 2 is 10, right? So we would go through and we would multiply and then go add a placeholder, 6 times 5, right? And then we would add everything up. That same type of process we're going to do, but with our binomials, all right? So we're going to use the expression from above. So I'm just going to stack one on top of the other. It's the same expression that we just did. Now, the multiplication symbol, I'm just writing off to the side so you don't confuse that for an actual x. So we're going to just follow the process and we're going to multiply. So I would multiply 4 times -3 and then 4 times x, right? 4 times -3 is -12. 4 times x is 4x. No carrying. That's the only thing that's a little different. It's okay, you'll see it. And then we put a placeholder down because now I'm to my next kind of place value. So then I would take x times -3 and then x times x. So it's the same kind of algorithm. So x times -3 is -3x. X times x is x squared. I don't know why it looks so far away on the screen. And then all we do is we add like you did yesterday if you added vertically. -12 plus 0 is -12. 4x minus 3x is x. And you see, we got the same exact answer as we just did on the other example. It's just another possible process. Okay. The third method that I want you to see is with an area model. In elementary school, it might have been called an array, if you guys remember that. So for an array, for example, if you were multiplying 24 by 63, you would make a square and you would put 2 and 4 and then 6 and 3. You guys remember doing that in elementary school? Yeah. Maybe. Depends on how your teacher approached things, but the reason this method is important for me to show you guys is because next unit, we're going to be doing something called factoring. And these arrays actually really help when it comes to factoring. Because for factoring, what's going to happen is you're going to be given this, and you have to tell me the 2 expressions. So it's like we're going to be taking this backwards next unit. And these array squares actually really, really help. But in elementary school, if you saw this, you would say 6 times 2 is 12, 6 times 4 is 24, and you would go through and you would write all these in and then add them together. So we're going to use the same type of thing here. So for the area model, I'm going to draw a square with 4 sections. The reason it's 4 sections is because each of my expressions have 2 terms. So I have x minus 3, or x and negative 3, and then I have x and 4. So all I'm going to do is I'm just going to multiply rows by columns. So x times x is x squared. X times negative 3 is negative 3x. 4 times x is 4x. 4 times negative 3 is negative 12. And then if I look through here, I do have like terms in that spot. So when I write my final answer, bless you. When I write my final answer, I need to make sure I combine my like terms. And then I get my answer. Yes. It looks like a Punnett square, yeah. Yeah, it has a similar setup. Not doing genetics with it, but it's very similar, look-wise at least. But yes, these are going to help us when we do our factoring, okay? You can multiply any process that you want. If you like the FOIL method up here, like where we just distribute, if you prefer this, or if you prefer the area model, whichever way you want to do it, okay? There's one last example. I do have another example like 5. We're not going to have time, but I will take a picture and post it up on Google Classroom in the notes, just in case you want more practice. So I will add another example up, but there is one other thing you're going to see in the homework tonight that I want to make sure that we cover. Okay, so I guess example 6. So you'll also be given expressions where you have multiple distributing to do. Okay, so it looks big, looks a little intimidating, but if you just take your time and like follow a process of order of operations, it's really not bad. So nothing I can do inside my parentheses, nothing I can do with my exponents. So I go to multiplication, which means I'm going to distribute. The 3 is going to distribute inside this expression. A negative 2x is going to distribute inside this expression. I have plus 5x on the end. Nothing we can do with that right this minute. Now for time purposes, and because it's a little bit bigger and because you've had some practice, we're going to go ahead and do the distributing mentally. So 3 times x to the third is 3x to the third. 3 times 4x squared is 12x squared. Negative 2x times x is negative 2x squared. Right? Remember, when we multiply the same base, we add the exponents. Then I have negative 2x times negative 7 is positive 14x plus 5x. I would say if you do that mentally, take a second and just double check your math. Okay, double check that you multiplied and handled your exponents correctly. Didn't miss a negative sign that was supposed to get used. Don't forget about these little guys at the end. that we didn't do anything with yet. And then the final thing to do is combine like terms. Okay, so distributing is like multiplication, combining like terms is like addition. So we're just following order of operations. So we have like terms here, and we've got like terms here. So my final answer is 3x to the third plus 10x squared plus 19x. Remember, when you combine like terms, the variables don't change. You just add or subtract the coefficients, right? Okay, questions? All right, so there are two things for me to pass out to you guys.